So a plane mirror is simply a flat mirror. Alright, so let's say you are going to check yourself out in the mirror. Okay, maybe you're going to look at some part of, let's say, your foot. You're going to look at your shoe. You're going to look at your shoe in the mirror. So the question is, how are you able to see your shoe? Okay, well there's two ways you could see your shoe, right? One is you could just look directly down at your shoe. For you to see anything, what has to happen? Light has to go into your eyes, right? So light's going to shine off of the shoe, and it can go straight to your eyes, straight up. Obviously, if you look down at your foot, you can see it. But the other way you can see it is if you look in the mirror. And so light's going to go off of the mirror, off of your shoe, into the mirror, and then how's it going to reflect off the mirror? The same angle. Okay, and it's going to head into your eye. Alright, but when you see the shoe, you don't see the shoe down here. According to your eyes, according to your brain, how should light travel?
Straight line.
In a straight line. So when you look at your shoe, it looks like your shoe is coming from a straight line, coming from back here. So the shoe that you see appears to be located behind the mirror, on the opposite side of the mirror, right? And if you were to look at all parts of your body, the same thing would happen, right? You would see a little guy behind the mirror. And that little guy looks just like you. Okay. Some other characteristics about the little guy is distances. So if you move closer to the mirror, what happens to this little guy? He moves closer. And if you could somehow measure the distance, let's say you could measure this distance. Let's call this distance DO. This means the object distance, where the object is you. This one over here we'll call DI, where DI is the image distance. And that's the distance away from the mirror of the image that you see. So in other words, if you could actually measure that distance, well, what's going to be true about those two distances?
DO equals DI.
So DO is equal to DI. For a flat mirror, for a plane mirror, those two are equal. And if you move away from it, that guy moves away. If you move closer, that guy moves closer, right? So that's kind of your reflection. This type of image we refer to as a virtual image. Virtual image as opposed to what we're going to see are called real images. A virtual image does not actually exist. In other words, if you go behind the mirror, are you going to see somebody back there? Okay, there's nothing back there, right? So it only appears to be back there because your eyes see in straight lines and you think it exists back there, but it doesn't really exist. Alright? And we'll talk later about what a real image is, because a real image actually exists. It's actually located there. Okay? Any questions on plane mirrors? Oh, let's look at one other aspect. Let's look at a top view of this. Okay, here's you. Here's the top of your head. Here's your eyeballs. It's going to be a top view. Here's the mirror. Here's your arms. Here's your hand. Okay, my artistry is not improved. So here we go. What happens if you shake your right hand in the mirror? What if you wave at yourself in the mirror?
His left hand shakes.
So his left hand shakes. Why does the image left hand shake?
Because it's inverted.
So notice what happens if we were to shine light off the hand into the mirror, it reflects, but then you see in straight lines, so the hand you see would be over here. And the left hand would come in, it would reflect, the hand you see would be over here. Okay, and so forth and so on. So if you shake your right hand, or wave your right hand, then this is the hand that's going to wave back, and that would be the left hand. So that image gets inverted when you look at it, where right looks left. If you've ever looked at words in the mirror, what happens to the letters in the word of words? Okay, they flip. Yeah, so they flip around. Okay, and that's the reason why.